Okay, this video is about the applications of linear and quadratic functions. It's 1.4 from the textbook. To give you an idea of the kind of things that we're going to be talking about, here's a classic rate times time equals distance problem. So if rate times time is equal to distance. So we have this problem. We have two cars which are 510 miles apart and whose speeds differ by 6 miles per hour are moving towards each other. If they meet in 5 hours, find the speed of each car. Okay, so I like to set up a table to kind of organize what's given to me in the problem. Okay, I have car 1 and I have car 2. Right, I have rate, time, and distance. So if we have car 1, we want to know the speeds of each car. We want to know their rates. So let's say car 1 is R. Their speeds differ by 6 miles per hour. It doesn't matter which car is which here. So let's just say the second car, it's 6 more. We could also say 6 less, and we're still going to get the same answer in the end. Okay. The time that these cars take to go, car 1, it takes they're both going for 5 hours, right? So one of them is going 5 hours, the other one's also taking 5 hours. That means the distance they travel, car 1 went 5 times r, and car 2 went 5 times whatever r plus 6 is. Okay, now we want to find the speed of each car, and we have information about distance. Their combined distance was 510. Like if one of them started here, one of them started here, this entire distance was 510. They went like different amounts of that distance, but their combined distance is 510, which means if I add up both of these distances, I know that that sum is 510. So 5r plus 5r plus 5 times 6, 30 is equal to 510. 10r is you subtract 30 over is equal to 480. Divide both sides by 10. R is equal to 48 miles per hour. Now in this case we said R was the speed of the slower car because we said the other car is going 6 miles per hour faster. So if the first car, like we would say car 1 at 48 and then add 6, this was like car 2 would then be, if we add 6, it would be 54 miles per hour. Now the other way of doing this, if you had made this a minus 6, then you would have ended up with a R is 54. You'd have to subtract 6 to find out what the slower car was, which would of course be 48. So you get the same answers either way you do it. Okay, now that's a sort of what we're going to be working with, but there's going to be another situation where we have a bunch of kind of really yucky looking rational equations to deal with. And so we need to review how you do rational equations. And we've already been sort of talking about this, but this is kind of a more advanced version. So the first step when dealing with rational equations is to factor out whatever you can right away. Okay, once you've done that, then you have to do what it says to do, so add or subtract or whatever. And to do that, we need to have common denominators. So in this case here, we can factor first, right? So the first one, this thing on the left doesn't factor, but in the middle, let's just write that again, right? K minus 2 equals this middle term factors, and I'm going to spare the process here because we have to do it in the next problem anyway. This is just K minus what do I do? K minus 5 times K minus 2. K minus 2, and then minus 9 divided by K minus 5. Okay, so we see that the common denominator is going to be the product of K minus 2 and K minus 5, which is what we have in our middle term. So in order to get common denominators on everything, we need to multiply this one by K minus 2 over K minus 2. This is fine. This is just 1, right? So it doesn't change the value. Right, this one here, K minus 5 divided by K minus 5. And then if we multiply the numerators out, on the left we'll have K minus, let me use the other color for this, we'll have K minus 5. That's going to equal, and don't worry about the denominators right now, we'll talk about that in a second, 1. And then this numerator, negative 9 times K is negative 9K. Negative 9 times negative 2 is positive 18. So that's our numerators. Now we have this denominator down here, right? It's K minus 5 times K minus 2. This is all K minus 5 times K minus 2. All right, we combine these two things. Now we don't actually need to consider the denominator here until the very end of the problem. The reason is because we have something in the form of like A over C is equal to B over C. And if this is a statement that's true, which says it is because of the equal sign, this means that A is equal to B. Because if something over c is equal to something else over c, then those two somethings have to equal. So in this case, the k minus 5 has to equal to 1 minus 9k plus 18. So for now, we're just going to solve in the numerators. Just consider the numerators. So when we do that, k minus 5 is equal to 1 minus 9k plus 18. We combine the k's, so we have 10k, and then combine the numbers, would be 18 plus 6, which is 24. So k is going to equal 12/5 after you simplify. Now, the denominators were still a thing. This is still a rational equation. And so what we need to do is to make sure that this 12/5, if we plugged it back into our original equation in any of these k's, so k here, 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 if we end up with a 0 in the denominators for any of those terms, then we'd have a totally undefined problem, and it wouldn't make any sense. So we don't have that in this situation. In fact, we could identify, looking at our original problem, what could k not have been? Well, k could not have been 5, and k could not have been 2. If it were either of those two things, if it were 2, this would be 1 over 0, which is undefined. This would be 9 over 0, which would be undefined. So we would have a problem. So as long as our answer for k, 12/5, isn't either 5 or 2, we're good. This is what's known as a domain restriction kind of thing, and we'll talk about that more later in this class. But here's another one that's a little bit gross. So first step, again, is to factor everything. And this isn't a video on factoring, so I'm just going to do this for you really quick. 2n plus 5. Here, we actually don't have to factor this top because we're going to need it later. So let's just leave this as 4n plus 10. But it doesn't really matter. You could factor 2. The bottom of this one, the numerator is 2n plus 3. Sorry, the denominator. This is n minus 2n plus 3 times n minus 2. Okay, minus 3n plus 1 divided by, and then this one factors to 2n minus 1 times n minus 2. And then this one is 2 divided by, and this factors to 2n plus 3 times 2n minus 1. So we can see then that in the denominators we have three things. We have 2n plus 3, okay, we have n minus 2, and we have 2n minus 1. Let's use blue for this, sorry. And we have 2n minus 1. So we need to multiply, all three of those things need to be in each denominator, which means we will have to multiply the right term by n minus 2 over n minus 2. We'll have to multiply the middle term by 2n plus 3 over 2n plus 3. And we'll have to multiply the term on the left by 2n minus 1 over 2n minus 1. Okay, when we do this, we're not changing any values, we're just getting common denominators. So now we're just going to focus on the numerators for now, and the denominator will come into play back at the very end. Okay, so if we multiply 2n minus 1 and 4n plus 10 together, we'll get 8n squared. Then we'll have 20n and negative 4n, so we have plus 16n, negative 1 times 10 minus 10. Okay, in the middle, 3n plus 1 times 2n plus 3. This will all be minus, so we'll have 6n squared. We have 9n and 2n, so plus 11n. 1 times 3 is 3. And then that's going to equal 2n minus 4. Distribute that through. Alright, so let's simplify this a little. 8n squared plus 16n minus 10 minus 6n squared minus 11n minus 3 equals 2n minus 4. So squared terms, we have 8 and negative 6, so we have positive 2n squared. 16n minus 11 is positive 5n, and negative 10 and negative 3 is negative 13, equals 2n minus 4. Combine like terms some more, so subtract the 2n over, we have 2n squared minus plus 3n, and then negative 13 plus 4 is minus 9, right? Alright, so that equals 0. And then we're going to need to factor this guy. Okay, so this is going to factor to n plus 3 times, n plus 3 times 2n minus 3, I believe. Yeah, that factors that way. Okay, again, if you need help factoring that, go watch the factoring video. Okay, so n is equal to negative 3, or n is equal to positive 3/2. The last thing we need to do is check to make sure that it would work in this and not produce a undefined situation in this original problem. So we could see just by looking at our factored terms here that n could not equal negative 3/2. It could not equal what's the commas? It could not equal negative 3/2. It could not equal positive 2, or it could not equal what's the last one? Positive 1/2. So since these are the two answers we got, it doesn't. They're none of those ones. So these two answers are correct. N is equal to negative 3, and n is equal to 3/2. All right, now let's get into some actual word problems here. Okay. So this is kind of similar to the previous one. Rate times time equals distance. So let's just draw our table first. Okay. I don't know how to draw a table apparently. Okay. So rate time distance. Rate times time equals distance. And we have two people here. We have Lily and we have Matt. Two former students of mine. Both competitive cyclists. Okay. So they start at the same location at the same time and they ride their bikes in opposite directions. So one's going that way, one's going that way, right? Now they're 140 miles apart, so their distances are going to be 140 miles. But we're trying to find the rate. Okay, so let's let R be Lily's rate. If Lily's rate is R and Lily goes 3 miles per hour faster than Matt, then Matt is R minus 3. Okay. The time that they're going to take, they both ride for 4 hours. So 4 and 4. That means Lily's distance is 4R and Matt's distance will be 4 times R minus 3. And their combined rate, like if this was 4R and this was 4 times R minus 3, their combined distance is 140 miles, right? So we're going to add these distances. 4R plus 4 times R minus 3 is equal to 140. So that's going to be 8R minus 12 is equal to 140. 8R is equal to 152. R is then going to be 19. Okay, so if R is 19, that was Lily's speed. That means Matt's speed. So Lily is 19 miles per hour, and Matt is at 16 miles per hour. We subtract 3 and get that. Okay, here's another rate problem, and this one is much more involved. This is the kind that we need those rational equations for. So I'm actually going to do the table up here because we need this space. So we're going to again have rate times time is equal to distance. Okay, and we got two people here. We have Ellie and we have Savannah. So how do I spell Savannah? Savannah. Okay, so we want to find in this problem, we want to find their rates and their time. So let's say that Ellie's rate is R. Okay, actually let's say Savannah's rate is R. And it says that Ellie rides 10 miles per hour faster than Savannah, so R plus 10. Okay, and let's look at their times here. So, well, actually, their distances. So we have information about distance. Ellie goes 60 miles. Okay, so if Ellie goes 60 miles, Savannah goes 50 miles. Okay, well, the time it takes, if rate times time equals distance, then time is equal to distance divided by rate, right? So this time for Savannah would be 50 divided by R, and this time for Ellie would be 60 divided by R plus 10. But we also have this other piece of information, is that it takes Ellie 2 hours less time to go her distance than it takes Savannah to travel that distance. So that means Savannah's distance is 50 divided by R. If we subtract 2 from that, Savannah's time is 50 divided by R. If we subtract 2 from that, we'll have the same value for how far Ellie went. Which means that this is also equal to 50 divided by R minus 2. Right? Because the time it takes Ellie to go that distance is 2 less than how long it took Savannah. Okay? So we can say, oh, looking at Ellie's time, we have two expressions for Ellie's time. So let's set them equal to each other and solve for R. So we've got 60 divided by R plus 10 is equal to 50 divided by R minus 2. Now we're just going to solve for R. So what's our common denominator here? Well, let's get the R stuff on the left side first. So 60 divided by R plus 10 is equal to, minus 50 divided by R equals negative 2. Okay, our common denominator is just going to be R times R plus 10, which means I'm going to have to multiply this by r over r, and I'll have to multiply this by r plus 10 over r plus 10, and then we'll have 60r minus 50r minus 100 minus 500. What is that? Yeah, 500. Okay, and then we'll have that's divided by r times r plus 10, and that's equal to -2. Okay, so if we simplify this, we have 10r minus 500 divided by r times r plus 10 is equal to -2. Let's multiply both sides by our denominator. We'll have 10r minus 500 is equal to -2r times r plus 10. Multiply this out. 10r minus 500 is equal to -2r squared minus 20r. Combine like terms. Let's move everything to the left side to make sure stuff is positive. We'll have 2r squared, 10r plus 20r plus 30r, and then minus 500 is equal to 0. All of this is divisible by 2, so r squared plus 15r minus 250 is equal to 0. Now this factors to r minus 10 and r plus 25. So we have our two possible rates, r is equal to 10 or r is equal to -25. Hopefully you see that this -25 rate doesn't make sense. How could you have a negative rate? Okay, so r is 10. So that means r was Savannah's time. So Savannah goes 10 miles per hour, but we also want to know what her time was. So 50 divided by 10 is 5 hours. Okay, Ellie, on the other hand, goes, and we know that her rate is 10 more than Savannah's, so it goes 20 miles per hour, and 60 divided by r plus 10 is her speed, or it's just 2 hours less than what Savannah's was. So she goes for 3 hours. So there's your answer to this. That one's pretty complicated because you end up with this quadratic, and you end up with this, this rational equation that you have to deal with. All right, here's a work rate type problem. These ones are notoriously difficult for students. Here's the key to this. All right, let's read the problem first. Gribble mows a mean lawn. He can mow a lawn in 45 minutes. He gets showed up by Anna on her rider motor, who can mow the same lawn in 30 minutes. If they both work together, how long would it take them to mow the lawn? Okay, think about what this is saying. This is basically saying this, that the work rate times the amount of time, how long you work for, is equal to your work done. Okay, so if I can mow an entire lawn in 45 minutes, what's my work rate? Like, what's my amount of work per minute, right? My work rate would be 1/45. I can mow 1/45 of the lawn per minute. After 45 minutes, I'll have mowed the entire lawn. Okay, that's the key understanding for this problem. So if we set it up, okay, again, we have work rate, time, work done. Okay, so Gribble and Anna. All right, now let's fill this out. What's my work rate? If I can mow the entire lawn in 45 minutes, 1/45 I can do per minute. Anna's, on the other hand, is 1/30. We do 1/30 of the lawn in a minute. Now, I don't know what the time is, right? But we're both mowing for the same amount of time because we're going to work together until it's finished. If we had different things, like for example, I started mowing and then Anna took 2 hours or 20 minutes later or something, her time would be t minus 20 because it would be my time minus 20 minutes because she got in 20 minutes late. All right, work done then would be t divided by 45, hopefully you can read that, or t divided by 30. Now, what does this equal? Okay, the amount of work I do plus the amount of work Anna does is equal to what? Well, it's equal to one full lawn being mowed, one job done, right? So now all we have to do is solve for t. The common denominator is 90, so this would be 2/2. This would be 3/3. And we will get 2t divided by 45 plus 3t, divided by 90, divided by 3t plus 3t divided by 90 is equal to 1. 5t divided by 90 is equal to 1. T divided by 18 is equal to 1. Multiply both sides by 18. T is equal to 18. So it takes 18 minutes working together. Okay, this is the same kind of problem for you have like pumps filling a pool, or you have people painting a fence, or copy machines completing a copy job, or something like that. So that the same procedure will be done for all of those kinds of problems. Okay, last one here is a mixture type problem. These ones will have a really bad rap also, but this can also be done with a table. And this one, it has to do with concentration of solution. So if we're adding some concentration, if we're pouring in a concentration, there's an amount of actual pure substance that we want. So in this problem, we're dealing with acid. So if we multiply the volume of solution by the concentration, we'll have a amount of pure acid in this problem. So let's set this up. Okay, we've got three things happening. We have pure, we have our 40% solution, and we have our combination at the end. Okay, you can call this like mixture 1, mixture 2, mixture 3 or something. All right, we also have a volume that we're putting in. We have a concentration, a percent, and then this is the amount of actual, like, amount of substance, like in this case acid. Okay, so let's fill this out. Our pure situation, just look at this, think about what this is. We want to know how many milliliters of pure acid must be added. So I don't know what this is, but I know that the percent of this, the concentration, is 100%. It's pure, which means that I'm adding a purely X amount into this solution. For the 40%, I have 50 milliliters of it. Okay, so I have added to 50 milliliters of 40% solution, and that is at 0.4. So 40%, 50 times 0.4 is 20. Okay. Now, when we add them together, our volume is going to be 50 plus X. Okay, our concentration of our combined thing is going to be 50%, so 0.5, which means the amount of pure acid that I have in my final solution is 0.5 times 50 plus X. So now, if you think about how something works, you're adding something to something else. So you're adding some amount of acid into some other amount of like distilled acid, and you're going to have some new greater amount of acid. So we're just going to look at this final column and add the top two to get the third one. So X plus 20, that amount of acid has to equal what's in the container at the end, which is this. Okay, so X plus 20 is equal to 0.5 times 50, which is 25. 0.5 times X plus 0.5X. Subtract 0.5X, we'll have 0.5X is equal to 5. X is equal to 10. So we need to add 10 milliliters of